But I think maybe he has some of the videos, I guess.
Yeah, the videos could be found, I think, in the. Okay, recording has already been started. So, okay, guys, thank you very much for coming. Welcome, everybody. So, I will just let me just share for a while my video. Can you see me over there?
Okay, yes, we can see you.
Okay, welcome everyone. Bismillah ar-Rahman ar-Rahim. So this is again another episode of the Coffee Hour series from the Energy Sphere at UNITEN. So I will share shortly my screen, but first let me just introduce this series for the newcomers or the watchers later on. You might find this video on YouTube later on. And this is just a series, we call that series Coffee Hour series. So we discuss general topics related to generally to postgrad students in the first place, but to anybody really, because we discuss so general themes and topics that include things related to research, related to learning, related to productivity, and to similar themes, related topics. So this will apply for anybody who is either a student, undergrad, or postgrad, or maybe a professional in the field, or let's say also it is applicable to any lifelong learner like ourselves. So we have talked about some things related to research previously, like publication metrics. We talked about the process of writing. We talked about a little bit hints or tips on productivity. And today we will talk about some tips about learning. So the title of this topic is about effective strategies for learning. I will share my screen now. I hope by now you can see the screen. Razin, Zahir, any feedback?
Yes, the screen is clear and okay.
Okay,
Yeah.
so again, this is from the Energy Sphere, which is an office space and a hub that provides a lot of services, including training, hosting meetings, hosting workshops, and other facilities in the University Tenaga National. And my name is Ahmed Mubarak, and I'm a senior lecturer in UNITEN. Uh, Specifically, I work in the IoT Planet Lab. This is one of the labs in the Energy Sphere. And again, the title of this topic is Strategies for Effective Learning. This will be entirely based, by the way, on this book. So this is like, you can consider it like a very short selective summary of the main points in this book. This is a very short, easy reading and popular book. It's titled Understanding How We Learn, a visual guide. So this is by a couple of researchers. So I refer everybody to this book later on. This is useful. It's short reading. It's interesting. The language is very easy to follow. So it's easy reading, friendly, and there are a lot of useful tips and useful ideas. So this applies to everybody who learns or teaches as well. So this is actually addressed or targeted at students and parents and teachers as well. So the main topics we'll talk about, this is just selective topics from this book, is first a little bit about the human cognitive process. This book is all about cognitive psychology. The authors of the book, these authors, Yana Winston and Megan Samaraki, these are from the field of cognitive psychology, and they are deriving some useful conclusions and results from cognitive psychology to the educational field. So that's why we will just introduce first a few ideas on human cognitive process, and then we will just present the main strategies. This is the main topic here, is the strategies for effective learning. These are methods or ways that you can increase the efficiency of your study. Specifically, we will talk to students, but this applies to parents and teachers if they wanted to adopt these strategies. So the 6 strategies we talk about according to the book, and also the book is accompanied by a video by a YouTube channel. So I would also recommend you follow that. These are the space practice and retrieval practice, elaboration strategy, interleaving, concrete examples, and last one is dual coding, using dual coding. So I will use their, they have generously, thankfully, provided some slides on their websites for free, with accreditation required, of course. And I will use their slides. But first, I will just talk a little bit about the first point here, cognitive process of humanity. So again, this is the book, which is the main resource for this talk. So if we look at the human cognitive process, we can talk about three aspects. The first aspect is the perception, because learning starts by perceiving the environment or perceiving the material you want to learn. So perception is the first aspect, and there's a couple of points I want to highlight in this under this aspect. Then we'll talk about attention, because of course, as we see, you need what is called attention to learn. And finally, we will just touch on the topic of memory, because sometimes if you understand a little bit, just a little bit, especially on the abstract level, which is called the cognitive level, not the neuroscience level, which is neuroscience is the more detailed physical level of how memory works or how the brain is connected and functioning. If you talk about the memory from an abstract level, from cognitive level, you might make use of some information, some data that can help in selecting and in understanding the strategies for learning. So for the first point, perception, we have to agree on something. First, we have to agree that when you perceive information, when you perceive something from your environment or the material you want to learn, when I talk about material you want to learn, this includes everything. It includes a textual material, for example, a textbook or something, a subject in a college, or some useful skill, like, for example, motorist skill or a physical skill, like sports, or, for example, some technical skill, for example, problem solving, or, some other skills like cooking, for example. Uh, Regardless of the thing you want to learn and the material presented to you, you first have to perceive this material, and you use your senses. Actually, we use the hearing and the vision mainly, but of course we can use also the tactile, the touches, and we can use the smells, and we can use the tastes. But mainly we focus on visions and hearing when we talk about perception. So we have to agree that when we perceive things, this is not an objective process. So perception is a process which is not objective. What does that mean? This means it is subjective. It changes from an individual to another individual. So we may have the same object in the real world, or the same material, or the same environment, or the same stimulus in the environment, and we may perceive this differently. So actually, the sensation will be the same. So here is another distinction. Actually, it's mentioned in the book again. So this distinction is between sensation, so the sensory image, for example, or the voice or the sound, actually the sound that's coming to your ear, or the picture or image that's coming to your vision system is the same. But sensation is not the same as perception. Perception is how you interpret those sensory data. So, and this actually is subject to a lot of things, especially to the context, what is happening now in your context, in your environment, and to your background information, what culture, what previous beliefs, what capabilities you have. So this will actually shadow some light on how you interpret the sensory data. So the subjective aspect of perception is important, because you have to realize that probably you have understood something wrongly, or not in the same way that was intended by the people or by the source of the material you are learning. So perception is subjective. That's a very important result. And there are a lot of examples, but I skip the examples for now, because although this is not very helpful, but because of time shortage. So you may, for example, refer to some optical tricks, for example, where they present the same object in different contexts, like the same colored box surrounded by different colored larger rectangles, and you will perceive the color of these same boxes as different, while they are the same color. But because of their surrounding, Maybe one is surrounded by a dark area, one is surrounded by a light colored area, so they will look different in color, although this is the same. So this is perception, difference in perception. You are not perceiving the color of the box um, as it is in reality, but because of the context, you perceive it. The sensory data is the same, but you perceive these two boxes as different. And this leads us to the curse of knowledge. This is very important in learning and especially in teaching, because when you know something, um, actually delivering this something to other people with different background and different contexts and different beliefs and different capabilities, this is very difficult, because usually it is very difficult to unlearn to the stage where you are in the same position as the learners. It's very difficult because you have many times to unlearn what you know. Otherwise, you won't be able to come to the level, the same background, context, capacity of the other people, so that you can deliver the message. You can teach them something. So when you learn, also you have to be aware of that. When you learn something, be aware that maybe the people who are explaining this, it could be the text in the textbook, it could be the lecture from the teacher, maybe they are skipping something because they suffer from this curse of knowledge. Maybe they know something and they cannot bridge the gap between them and yourself. So leave some room for some gaps to be filled later on, and also try to be objective as much as possible. Means try to also think of the perspective of others, so that maybe you can understand. Sometimes you can click, you can understand the concept if you just let go of what belief you have about this specific matter. So this is the first concept about human cognitive process. Let's move to attention. This is a very interesting concept. Attention is very important, especially for learners. When we talk about learning, please be aware of at least these 3 points. Here I listed 3 points. The first couple of points are very, very important. I would like to highlight from the book, although these are not strategies by themselves, but these are important information to move into making use of the strategies. First thing to know about attention. By the way, when I say attention, you might seek for a definition of this concept, attention. It's very difficult to define that, but I will rely on the intuitive understanding of attention by everybody. So scientifically, if you go to the cognitive psychology or neuroscience, probably people will fight to just agree on a definitive definition for attention, but we will skip that. We don't want to write a paper. We don't want to establish any knowledge here. We just want to deliver a few points. So we will rely on the intuitive meaning of the attention. So we know that when you pay attention for something, you are restricting your focus. So your ability to notice, to see, to hear, and to think about something, your focus on one thing and excluding many other things at one given point in time. So at the same time, you don't split your focus into more than one thing. So you are paying attention, means all your resources or your capabilities of the sensations you have and the thought process you have are focused on the same thing. So this attention, first, you have to know that it is a limited capacity resource. That's very important. So it is like a battery in this in you know, it's a charged battery. For example, you have in the beginning of the session, study session, or the beginning of the day, and if you spend too much of this resource on something, you are depleted of that resource, and you probably won't be able to pay more of that resource to other things. So that means that you have to be selective and you have to be aware of what you pay attention to. And because this is a limited resource and you cannot pay like a budget you have. This is an example I remember from the book, like a budget you have per month. So if you want to dress expensively in one month, you might not be able to go to a fancy restaurant, for example, in that month, and the other way around. If you spare some money and you just decided to, for example, transport minimally or dress cheaply, then you may be able to go to fancy restaurant and have a very expensive meals because the budget is limited. And the same, attention is a budget which is limited, which is capacity resource which is limited. And if you pay attention to something, you won't be able to pay attention to other things. In the same time, for sure, but also afterwards. For example, if you focus too much on something, you will have less resources to pay later on to other things. About what you pay attention to. This is very important aspect and very important result, because selectivity is important also, if you remember from the last talk, also in the context of productivity. You can't be productive if you are not selective. And this applies here also. From this result is also confirmed from the field of cognitive psychology. The second result here from attention is that there is a myth of multitasking. And we talked about that when we talked about productivity. But this is again confirmed by the cognitive psychology, and the book is talking about this again. So multitasking is a myth. Multitasking is harmful. So you cannot do actually more than one task, paying full attention to both tasks, unless you compromise the performance, your efficiency in both of them. Of course, this doesn't apply to some tasks that are usually run in the background, because as we will talk later on in the memory part, there is something called procedural memory. Sometimes there are some procedures like mechanical memory. So you are remembering something uh, out of the habit, and you don't need really to pay attention and focus. Like, for example, you can drive and talk at the same time. So you can focus on your talk. You can focus on your talk, and you may be talking about some really deep topic, like, for example, you may be debating with a friend while driving at the same time. But driving is a procedural memory. So you have that in your procedural memory. So you are not really paying attention, paying your focus. So that doesn't apply to multitasking. Multitasking, when you need your focus, you need your attention to two tasks, because they are not very easy, they are not very habitual, and they need a minimum amount of focus. This is attention in this regard here. And then you cannot split your attention between these type of tasks. So one reason for that is that our mind is single processing unit, actually. So like a CPU. When we teach, for example, processing computers, we know that there is a single process system and there are processor systems. So our brain is like a single processor system. This means that even a single processor can do many tasks, but it is switching between them. So a single processor, like my laptop, for example, if it were a single processor, now it's rarely to find a single core processor. But in previous decades, we used to have multitasking in our computers. You can run, for example, the Explorer while the operating system is running, while you are running a calculator and maybe typing something in Microsoft Word. This is possible because this multitasking in computer systems, this is referring to the operating systems, this type of processing is done in sequence. But the processor is switching so fast between one process, one program, one job, and the other one. So this switching is happening so fast that you are under the illusion that these are happening in parallel, concurrently. So they are looking like concurrent, but they are performed in sequence. So this is the same what you do actually. When you do what is called multitasking, what you are really doing is you are just switching between two tasks very fast. Probably you are used to do that very fast. So for example, you may be watching something on YouTube while reading a book. Actually, you cannot do the same. You cannot do two things in the same time. But maybe you are used to switching too fast between these. What's the price you pay for that? Is that there is something called a switching overhead. So you pay some cost when you switch from task A to task B. And this switching overhead could be very, very expensive. So some studies say that, for example, if you have a full focus on some difficult task, and you switch to another difficult task, and you want later on to come back to the first difficult task, then the span of this switching overhead, so the time that takes you to switch successfully, so you retain the initial focus that you had on the first task, it might go up to it might go up to 20 minutes. So it might be 20 minutes until you go fully into the mood and the focus that you were in the first place. That's why please
Subjek
be
apa ni?
aware of
IoT
the
Dia
myth of
lecturer apa?
ineffective.
Komputer Lecturer komputer? Oh,
The last
engineering.
point about attention aspect is that, just sorry, the last thing about attention is that because our attention is a capacity resource which is limited, is a resource which is limited, you can pay so much attention only, then you are depleted of this resource. You have to be aware of how to use it. Okay, and this leads us to something called, we will talk about this in memory when we talk about memory. This is leading us to the concept of short-term memory. Usually when you pay attention to something, especially when you want to learn something new, um, usually first you perceive the information, you perceive something from the environment, some stimulus, some material that you are trying to study or to learn, and you will take into your memory, into a place called short-term memory, a very limited amount of that information that you can retain for a very limited time. What you have to do, you have to move that amount into the long-term memory. Otherwise, you will lose it just shortly after maybe 15 to 30 seconds. So you have to be aware of the short-term memory. It's very limited. That's why don't try to overcrowd your short-term memory. So lot of studies showed that the different objects, the different things that you can keep in your short-term memory. For example, many studies use numbers, figures, to just represent or just to exemplify what is the things that you can keep in memory before before transferring to long-term memory. Many studies show that this is between 5 and 9 things, and many more studies. I think I read this many times. Some studies show that these are only four different things that you can keep in your short memory before you forget, or you keep in your long-term memory. So just be aware of that, because it's not surprising and it is not disappointing if you just learn something new, some new amount of information, okay, some pieces of information, then you forgot this information. That's a natural actually mode. So you have to forget actually that's because you have a short-term memory. Unless you do something to move it into the long-term memory, naturally you will forget it. Just be aware of your limitation, your capacity. Some people can take 4, some people can take 5. Most people take maybe 6, maybe 7, up to 8. It's very rare that people can take more than this. For example, you can recite um, uh, 5 numbers, and they can then take it and recite it again in the same order after a while, after maybe a few seconds. Of course, we talk about seconds, scale of seconds, 15 to 30 seconds. So of course there are studies. For example, one study many years ago, they trained a person, they trained the person for 2 years for 2 years, until this is under the study of deliberate practice. Sorry, deliberate practice. This is a very famous book called Peak, which is talking about the deliberate practice and how deliberately you can improve your learning. But for example, for this person who was trained for 2 years just to remember things, to extend their short-term memory, it was successful. They could extend, and one person reached up to 80, and another person maybe exceeded that limit. So 80 different number could be just stated or recited, and until after this series of numbers are finished, they can repeat these numbers in the same order, that these have been stated in the first place. This is very rare and really not very useful. So you don't need this kind of capability. You can extend your short memory a little bit, but you don't need this capacity really. You always can read, you always can perceive new information, move it into the long-term memory, and then apply some of the strategies we'll talk about shortly. The final aspect of cognitive process in humans is the memory. And just very shortly, few points about memory that might be useful when we talk about strategies. So the first thing is memory is reconstructive. It is not objective. Reconstructive means it is not like a library. It is not like a hard disk. It's not like RAM. Many people use the analogy of computer memory or the library when they talk about memory, which is wrong scientifically, according to the book, according to the cognitive psychology. It is wrong analogy, because they are not the information we learn are not just stored and kept in specific pieces like shelves, for example, or drawers labeled with very clear labels and tags. That doesn't happen. So what is happening is that there is a very complicated process, and whenever you store somehow, we'll talk shortly about this here when we talk about encoding. Whenever you somehow store using some chemicals, some information in many different neurons in your brain, whenever you try to retrieve, which is part of learning, whenever we want to retrieve this information, actually this information the memory is reconstructed. It's not just taken as is from the cell where it was stored. No, it is actually reconstructed. This means that it might change. It might be modified. It might be changed somehow. So reconstruction means it is subjective, because maybe the first time you tell a story, you remember it somehow. The next time, after retrieving it, maybe 1, 2, 3 times, you're reconstructing the memory. Probably a few details will be added, few details will be removed. That's why testifying, and that's why when you are witnessing something in court, it's not a very easy task, and it is very complicated and it's very dangerous. And so don't rely, this is the golden advice, don't rely too much on your memory. That's why many people, they ask you to just use external memory and you just some aids, because remember, you cannot treat your memory, your brain, as a computer system. The same bit you put in, you will receive later on. The same bit goes in, it will go out. It might not be the case. So, and we talked about short memory. There is also long memory. There is a declarative memory. Declarative means when I ask you to tell, okay, to, for example, memorize something out of your memory. But sometimes I don't ask you directly to declare and to state what you know from you have learned something in memory. But maybe you just perform, like I give an example like driving, or some example like playing some kind of sports, or maybe some kind of going back home from somewhere while you are thinking about something else. So you find that your memory, there is a procedural memory that can act out of previous learning without conscious declaration, conscious recitation of what you have learned. And finally, these are the steps that goes into the process of moving the information to long memory. I talked that you have to move information to long memory. So there is a step of encoding, and this involves a lot of neuroscience terminology we will avoid here, but you have to know that this information somehow, these are represented in terms of signals in the neurons. These are cells in the brain, and neurons, multiple of neurons can be activated with this new information. The group of activated neurons is called engram, and multiple engrams could be linked together with synapses, and these multiple engrams is called associations. So whenever you try to elaborate on the new knowledge, try to do something. Elaboration means give concrete examples, ask questions about it. We'll talk about these strategies shortly. Then you consolidate this information. So you strengthen these synapses, you strengthen the connections between these cells, or these engrams, or these engrams are actually a collection of neurons. So after consolidation, you move this into long-term memory, but you have to retrieve it. And each time you retrieve it, there is a reconsolidation and reconstruction for the memory. And this is called retrieval practice, which is very important. You have to retrieve practice and so that you can strengthen and reconstruct and reconsolidate these pathways between engrams and build associations. So you learn well. Otherwise, this will not be able. You will not be able after a while to retrieve. Even if the information are there, you won't be able to retrieve it. So that's enough about the cognitive process of humanity. Let's now move into the meat, and shortly we talk about the 6 strategies. So as I told you previously, again, for the newcomers, I am talking about this book explicitly, and these are the 6 strategies we'll talk about using the slides generously provided by the authors of the book on their website. So please look up this, Understanding How We Learn. This is a very good book. It's a very easy reading. It's a short, and the language is very easy to read. It's approachable, And then you can also refer to the website provided by the authors. So this is called the Learning Scientists website.com, learningscientists.com. And you can find easily this on Google. So I will now switch to their slides talking about specifically these strategies. So first we'll talk about the most, let's talk about planning the learning first. So you want to study some material. Actually, again, when we talk about learning, we don't talk only about, classroom. It is mainly about classroom, but also when you want to learn a new skill, a new sports, physical skill, cooking, some technical skill, or of course, learning something from textbooks or from tutorials like programming skill, math, science, history. You want to memorize some things. So these are all of these kinds of information are subject to these strategies. So first, as a planning, let's talk about this. This is the first strategy I'll talk about, is called spaced practice. So again, these slides referring to the learningscientists.org. Sorry, it's not .com, it's .org. Learning Scientists. This is the website by the authors of the book, which is the main reference, as I introduced previously, of the talk. And these are the main strategies: and retrieval practice, space practice, dual coding, interleaving, concrete examples, and elaboration. Some of them are easy to understand, and some of them will be surprising for some. But these are strategies, means these are things you are urged to try when you want to learn anything new, and also when you teach anything new. So you also advise to encourage your students, if you have students, to, or your kids, for example, if you are a parent. So the first thing is space practice. What does that mean? Space practice is that, just in a short term, okay, don't cram. So no cramming. So don't cram everything in the same place. If you have an exam, or if you want to learn something by deadline, don't wait until it is too late, or until, for example, maybe you dedicate, it's not too late. Maybe by design, maybe by your own planning, you just decide that, okay, I will wait until it is 2 days before the exam, or before the presentation I have to give, or before anything you want really to learn, a deadline for learning. And then I will do that just 1 day or 2 days, and I will just dedicate myself within that 2 days, because I want the information to be fresh in my mind. So I want the information to be fresh, and I actually want to study or to start early on, because probably by the time the information is required, I will forget that thing. Actually, this is proven in many experiments by research. I mean, I am referring to academic research, that this is not the best practice, which is cramming. But the best practice is the opposite. You space the practice. So instead of focusing all the study in one time, you space that out. So you distribute your study over long sessions, long period. For example, if we refer to an exam, that would be maybe 2 weeks before the exam. Of course, if you take a class like in the university setting, you have to do that over the semester. But just we are referring to an exam, for example, something you want to study for, like a certificate, for example, something specific. So 2 weeks with distributed study, short sessions would be much better than one session just before the exam. For example, let me just take some example from here. If you have, for example, 5 hours here, if you have 5 hours spread out over 2 weeks, is much better than the same 5 hours all at once, maybe the day before the exam. This is proven by scientific experiments, by the way. So, and actually, really, it's intuitive. I don't know, for me as a lifelong learner, I found that many of these strategies that are coming from cognitive psychology as intuitive, because we have been practicing this, maybe not all of us, but many of us have been practicing this since decades, because it looks right. And this is, of course, the case. Sometimes we don't have the luxury. Sometimes it's too late because we are lazy. But if you have the chance, of course, dedicating short sessions, they have to be short. So, for example, instead of 5 hours in a day, maybe 1 hour per 5 days spread out over 10 days. So one day every the other day, every another day is 1 hour. So many people, when they advise to study a course, for example, I am doing this online, for example. Probably I cannot just finish all the material for one online course for a week in the Sunday and Saturday, although I am working all the days and I don't have time. But it's not practical. It's not really effective. This is not effective to just study on Saturday and Sunday the material of all the week. Maybe probably if I do half an hour or 1 hour, maybe every day, half an hour every day, 5 days only, or maybe 2 hours, maybe 2 days or 3 days, 1 hour and a half every day, spaced over 1 week or 2 weeks, that would be much better. And there are some cognitive explanation for that, but this is beyond the talk. Just the result is, please distribute your study. So this is called spaced practice. So when you practice learning, you have to space, you have to plan. That's why it is called planning here. This is called planning because in this way you have to plan ahead. So you don't wait until it's too late, but you give yourself a fixed schedule. You have to set up a fixed schedule where you set learning time and you split whatever course or courses you want to learn over these sessions, which are fixed and scheduled over weeks. So you review the information from each class, but not immediately after the class. This is another thing. When you have space practice, okay, you take the lesson here. I just please follow up with the illustrations here. I am referring to the illustrations on the same slide. So here you have a lesson on the left, and then you have a break, and this break could be in the same day in the night, or could be maybe the next day. So then you do a review. So this is the first spaced session you have for your lesson. I always advise my students to do a session before the class, just to be familiar with what will be said, and then you attend the class, is second session. Then you wait until the night in the same day, not immediately after the class. This is not very helpful, but maybe in the night or the next day. Then you have to review the first session. Then the next session you review the previous lesson, and then the lesson before 1 week you go back. This is a retrieval we'll talk about later on. So this is illustrated here, and we will talk about this when we talk about retrieval practice. But in short, after you review information from the most recent class, make sure to go back and study important older information to keep it fresh. So whenever you review, of course you will review the material from this day in the morning or the previous day, 1 day ago. Don't forget also to review 1 week ago, 1 month ago. This is called a retrieval practice. It's very, very useful because it overcomes this one. I will just show you because it is not in the slides. There is a curve called the forgetting, or actually retention curve. Whenever you have some new information, your retention will be very okay. At its peak, it will not be 100%, but it will be somewhere here for the information. When time goes by, okay, this is what will happen to your retention. It will decline. It will just go down, and this doesn't matter what is the span of this period. This could be seconds or could be days. The results are the same. These are also referring to academic studies. So this will go down. So what happens if you wait until 1 day, like here, or 2 days or 1 week, then you review the information. Actually, this is what you are doing to the curve. You are bringing it back here. So you are delaying the decline of the curve. And then after this, you just interfere again after a while, 1 week. Then you are delaying. So eventually the curve will look like this, much better than the original curve. So your retention, your long-term retention of the material will be longer than if you don't interfere, if you don't review this material on a regular space practice. Of course, you have to be aware that when you sit down to study, make sure you are using effective study strategies rather than just rereading. So when we talk about reviewing, it's not only rereading. There is another one called retrieval. We'll talk about this shortly in a couple of minutes. And also remember that this will look like difficult. So this may seem difficult and you may forget some information, because if you space the retrieval, if you cram everything in 1 day or 2 days, probably you will remember better at that session. So in the same session, you will feel that, okay, you remember better because you just read that, 1 hour ago or last night. But on the long term, on the long run, this is much worse, really. It looks like, oh, you don't remember. But actually, if you do this spaced practice on the long run, that would be better for your learning, especially long-term learning. We're not talking about just passing the exam, then forgetting everything. We talk about taking the information, building on that information, using that information for the next classes and next years. So it will look like hard, but just keep with it. Everything good is hard, really. And then you just keep create small spaces, maybe a few days. That would be typical, and do a little bit over time, so that will add up. That's about the first strategy. Let's talk about the second strategy, which is I'll talk about the most important strategy, actually, which is retrieval practice. This is the most famous, the most important, and the most proven, actually, strategy among all strategies. So this has been proven so many times. And actually, again, I find it intuitive. I used to do this when I was in primary school. I am sure many of you, this seems very straightforward, very trivial. But actually, a lot of studies take a lot of time to just prove this. Retrieval practice means whenever you study something, don't just read it and reread it, and that's it. You have to close the book at some point. You have to go away from the material, and then you have to try to retrieve all the information on your own. So that maybe you sketch the diagrams, maybe you rewrite everything, you explain everything, maybe you answer questions. Most probably you will answer a lot of texts or tests, like questions or tests. Maybe you will discuss that, maybe you will teach that for somebody else out of your notes, away from your book. I used to do that when I was a kid. Whenever I used to actually memorize a lot of the whole book when the books were small, of course. And then after that, I will give this to my mother, actually, when I was just a kid. And then I will recite all of this for myself. And sometimes before the exam, you just give somebody your book and ask them to randomly ask yourself. This is retrieval practice. And although it is obvious, it looks very obvious and very intuitive and very trivial, but it turns out, because many people do studies on this, it turns out that many students don't do that. They just choose to read the material and just flip through the slides or the book, and then probably reread again. Actually, many studies, overwhelming studies, have proven that rereading the materials twice in the same session is much less effective than doing retrieval practice even once, even after a week, especially for long-term results. So you can put away your class materials and write or sketch everything you know. Be as thorough as possible, means try to retrieve everything you can remember. Then check your class materials for accuracy. This is very important step, by the way. After you try to recall and retrieve what was studied by answering a question or trying to reproduce the information in your own words, or by teaching this to somebody, you have also to refer back to the notes and make sure you were correct, because most of the time you will miss a lot of things and you will not be correct. So you have to correct information. Otherwise, it will be harmful, because you will just reinforce wrong information. You have to correct, and you have to bring that curve back in the right place. So you have to check your class materials for accuracy and important points you missed. And of course, if you have the help of somebody else, like your roommate, for example, your friend or a relative, you can ask them to ask you something and correct you if you are wrong, or fill the gaps if you are missing something. So it takes as many practice tests as you can. You can take as many practice tests if you have practice tests, or you can make up tests and exchange with your friend. If you don't have ready-made tests, try making your own. You just make up your own tests and maybe trading this, exchanging this with a friend who has done the same. This is just to increase the amount of questions you practice the material. You can also make flashcards. This is very, very famous mechanism, or very famous way. You just put a piece of paper, you write some definition or a concept or a diagram, but you have to make sure that you flip this, or you just throw it away. Don't just look at the answer very early, because many people, they see the question and the answer is in the back of the paper piece, So then after, just before they finish answering, they miss something, they just flip a little bit, means they cheat a little bit. So just make sure this is away. You are away from the answer until you finish, then you correct yourself. So the retrieval practice works best when you go back to check your class materials for accuracy afterward. And retrieval is hard, of course. I guess, although it's very obvious technique, it's very trivial, as I said, very intuitive. I guess because it's hard, so many students avoid it. That's why it is disappearing from the culture of learners. So if you are struggling, identify the thing you have missed. There is another very great beneficial for doing this, is that when you practice retrieval, it's not only you reinforce, you consolidate, you move the information to the long term. Not only that, you also discover the weak points. You discover what you don't know, what is information you are missing a lot, and what you get correctly wrong. And then you have the chance to correct that, and you have the chance to fix that. Otherwise, if you just read and reread, you won't really know what is you really learned and what is you just see in front of your eyes without moving into the long-term memory. So don't only recall words and definitions, make sure to recall also the ideas, means the understanding, not only memorization, but also understanding. So this is about retrieval practice. Let's move into the next one, which is interleaving. Interleaving is also, it's not very much proven like, space practice and retrieval practice, but it is still important and intuitive, I think, to an extent. There are some caveats, so I will just highlight that. Interleaving means when you sit in a session, okay, you don't just do one topic. So you don't just spend the whole session like 1 or 2 hours, only a single lesson or a topic. It's better to switch. Remember, switch is harmful if you are overdo it. Switch between ideas, maybe between 2 lessons or 3 lessons from related topics, related subjects, but not same and not very different. So for example, physics and math. Because first, this will allow you, for example, lesson from a math, then next a lesson from the physics, from the from the classes today. Maybe first of all, you will be able to distinguish. There is a distinction between the two, so you will not mix the information up. Now you study math too much, then you study physics too much, then you forget really what goes where. When you see this in succession, maybe you have better chance to distinct between the two material. This is one. Second one, more important, you might be building relationships. You might be relating things, and one subject might help you to understand another subject. This is not happening all the time. It depends on the topics, especially if they are related but not the same, but similar. But some studies suggest that this is more helpful than just focusing on one thing in one session. So you sit for 2 hours one session, study for this today, in one subject only. Better to just try 2 or 3 subjects. Try it out, might be helpful, but don't overdo it. Switching is not happening every 50 minutes. You have to have enough time to understand what is the point in this subject first. After you finish it, then you move to the next subject. So don't just switch before finishing the understanding of this one subject. So also the next session, maybe tomorrow, you also have 2 or 3 subjects. You change the order. This is also advisable here. You change different order. You have different order. So previously you studied math, then physics, then, for example, computer science, let's say, and now you study computer science and math and physics. And try to make links between the different ideas, because that's the actual usefulness of this. Okay, that's enough for interleaving. The next strategy is elaboration. Actually, I will combine all of these 3 in the last few minutes. Allow me to combine all of these, because all of them are actually elaboration, and this is very, very important. So elaboration first means you are not just reading and tackling the new material on the surface. It's not shallow learning. You go deeper and you try to link the new information to the information you have previously. This is very important for, remember, consolidation, moving information to the long-term memory, and for reinforcement of learning. So you can think about 3 different aspects of elaboration. One is what is called here it is called the elaboration, but let's call it elaborative interrogation. This is called in the book, which is just questioning. So when you, simply put, when you learn something new, whatever you are reading this for yourself or taking this from the class, in the lecture in the class, or from YouTube channel or YouTube video or something else, don't just take the material as is and try to memorize or just understand what is said. You won't understand it really until you elaborate on the material. How is that done? Most important thing, ask questions. So you ask yourself questions while you are studying about how things work, especially two types of questions: how and why. Why is very important. How and why. Why goes in depth. It really try to link things with each other. So if you have long old information, you can relate new information. Maybe this causes that, maybe this is related to that. And also how makes you go into the depth of what is presented to you. So for example, you don't just say, for example, oh, there is a device, and let's assume you are some student in electricity or electronics course, and you want just to understand, presented to you some kind of a device. Okay, so you don't just say, okay, I am studying, like, let's assume, transistor or something else, and I know that there are three terminals. Electrons is gone from here, that, and we collect things from here, and we need to control something from here. That's it. This is on the surface. Probably you can draw the diagram, and you know the terminology, and maybe you can even describe the process, but really you don't understand how exactly is this done and why the electrons are coming from here and why they are collected from here. What is going on inside, on depth? So try to ask yourself. If it is not obvious from this lesson, go to other lessons. Ask questions, probably to yourself or to the teacher or to the lecture or to the next video or to the next chapter in the book. But elaboration in this way makes information stick for long term, and partly not because of the depth of the level of the depth you go in, but also you are interlinking information with previous knowledge, with all the the fundamental physics you have studied before, the way atoms are working, the way devices are built in. So you are linking all of these. Whenever you add some new layer, it is linked to the previous layer. That is very difficult to forget, very difficult to misunderstand. So this is one way, means you just ask questions and you try to describe. When you ask, you try to answer. And whenever you get the answer, you try to describe the ideas you study, or explain to somebody else. So you have to make sure the way you are explaining and describing an idea is accurate, because you have to consolidate your learning accurately and correctly. Otherwise, you will get the wrong reconsolidation. So uh, you will even damage or corrupt the information you have previously if you are not bringing new correct information. The other aspect of elaboration is concrete examples. This is very important as well. And I know many of us deals with this as very intuitive. Of course, without examples, it's very difficult to understand abstract ideas. So examples are very important because they help us to bring the abstract into the concrete. They make the link between the idea you are studying, anything is presented to you in the book or in the lecture, and the examples you can think of, or the examples given to you. For example, when I say I am teaching, just example, I'm giving a definition. I'm teaching, for example, parts of a CPU. I'm saying there is an ALU unit. And a student asks, what is ALU? I say arithmetic logic unit. So it's obvious, arithmetic and logic unit. So this is an abstract, but it is a definition after all. But when I say, oh, arithmetic like add and subtract, multiply, divide, logic like and, or, XOR, I give examples, concrete examples. This makes a lot of sense. So you feel that, okay, you get the point. So you start to understand the concept. Another example given in the book is about scarcity, for example, concept. Something is rare. It is an economic concept, but people don't understand this until you give an example. Okay, the tickets, for example, of line tickets, before a few months, it's cheaper, okay, relatively. But when the trip is becoming closer and closer, and the seats are less and less, probably the ticket will go more expensive. So this is the concept of scarcity. It is linked to a specific example, but be aware that when you give examples, when teaching something or when learning something, when you take examples, don't focus on the example too much, to the extent, this happens with many students, they just remember that this concept is related to this example only. So they cannot generalize. Sometimes, especially young students, they fix their mind with the example only, and that concept links directly and exclusively to that example only. That's very harmful. That's why I don't like, and beginning, even at the university level, I don't like beginning my I don't like beginning my explanation with, for example, giving an example, just concrete example, then the concept. So I would like to just at least introduce the basic idea, the basic concept, then supporting it with examples, so that they don't miss the big idea, the big picture. So that's the most important thing to remember about concrete examples. So you have to look for examples when you learn something new. Share examples with friends, explain them to each other for added benefit. You may find examples on the internet that are not used appropriately. Avoid that. Only take examples from authentic and appropriate resources. You can create your own relevant example, as it is written here, creating your own relevant example. But again, be careful, because if you are novice, if you are beginning in some topic, it's very difficult to come up with good examples. That's even difficult for teachers, for experts. So the last thing we'll talk about today is dual coding. Dual coding is very easy to understand, and that's the last thing I will talk about, which is just make connections between text and visuals. That's it. So dual coding means you are using two types of coding for the same information. So look at your class material, whatever you are studying or whatever you are learning, and find visuals if you can. So if it is text, probably you try to visualize it. If it is visual or a diagram, try to add some text. This dual type of information coding is proven in studies to be much better for understanding. Of course, this doesn't relate to the learning styles that some people are like auditory, some people like visuals, some people like what they call it. They learn by just, it's better to learn by visualizations. I forgot the term used to that. And some people are auditory. They are better learning by, for example, hearing the information. Actually, this type of learning styles, this has been proven to be not really effective. It's kind of, there is no concrete evidence that this actually works. So this doesn't relate to that. Actually, whether you like diagrams best or whether you like the sound or the voice best, if you have new information, just use both. Just use both modalities. Use the visuals and use the textual information, and that will be good for everybody, whatever their preferences are. So look at visuals and explain in your own words that they mean what they mean, and take information that you are trying to learn and draw visuals to go along with it. And the same, if you find textuals, you produce visuals. If you find visuals, you produce text. That's the idea here. Try this as much as possible. So for example, you read about something that happens in events, happens in chronological order. Probably you can just visualize it using the timeline, or you can visualize it using cartoonist drawing, or using some infographic, or using some scientific diagram like this one, or using some graph. So that's it, guys. I hope that just very short summary of what we have said. So what we talked about is the following. First, we talked about some cognitive processes for humanity. All of our talk was based on this book, so please look this book up later on. So we said there are three aspects we pay attention to is the perception. Perception is subjective, and you have to be aware of the curse of knowledge. Then we talked about attention, which is a very limited resource, and the myth of multitasking, and the concept of short memory, and some aspects of memory, like memory is reconstructive, it is not objective, so you have to be aware of that. And there is something called long-term memory, so you have to reconsolidate your new information to move information into that memory. And you have something called procedural memory as well as declarative memory. and there are some steps that goes from neuroscience perspective into the brain to learn something new. And then we focus on 6 strategies. So please, I encourage everybody to try this at least once. You space your learning. It is not necessary you are attending classes now. Probably like myself, you are taking online courses, for example. You are a lifelong learner. So try to space your learning of courses over long distances. Just fix some schedules for yourself and try to practice retrieval. Don't just open the book and read. Even if you reread 2-3 times, it's better to close the book and try to retrieve the information, recall everything from the memory, from the long-term memory, and try to switch between different subjects. Don't just focus on a single subject in a long session, and try to elaborate always, either by asking questions, why and how, or giving concrete examples, or using different types of coding like visuals and textuals. I hope this was useful for a little bit, and this is the end of my talk. If there is any addition of some of the guests, or you have some questions to ask for the others, then you are most welcome. Otherwise, I'm done with the talk. I hope that it was not very boring and that you're not killed with boredom. So sorry for taking a little bit long time. We started late actually. And now I open the door for any addition or any correction on your side. Please go ahead.
Okay, good afternoon, Doctor.
Afternoon, Razin. How are you?
Okay, so I have a question. Let's say like the question is like every day I think we are exposed to like certain knowledge or maybe information. So how do we like separate that knowledge or maybe information like systematically so that we can access that particular knowledge like without any like interference or something? Is that a way like that is my question?
Means you have different types of information. You want to be able
Yes.
to. Okay, actually, I didn't. We didn't talk about this too much because this strategies focus on some aspects, which is for learning. You know, it is not exactly what you are talking about, although you can find some connections. But I would like to give some tips on what you say. Actually, what you talk about, probably the most thing, the closest thing I can think of related to this question is what people always advise of using an external memory. It's very important. We said that when we talked about the cognitive process of humans, we have to admit that we have limited attention and we have limited memory, and especially the short-term memory is very, very, very limited. And when you have overwhelming amount of information, new types of information, and you are really afraid of mixing up these different kind of information, probably the best strategy is to use external memory and to use what is called cognitive offloading. Sometimes, I didn't talk about this, but it is mentioned in the book. There is something called cognitive load. This cognitive load is the typical amount of information when you learn something new. It is very harmful if you have cognitive overload. Overload means you have too much, so you cannot take it into short-term memory, and you don't have even the time to take it into the long-term memory. So probably best to do cognitive offloading. Cognitive offloading means you have certain amount of time. Your day is very short. Probably the office hours are very short, and probably part of the office hours you will use for learning. And you have a lot of information coming from different sources, different subjects. So try to receive the information, offload cognitively this by using an external memory. So you have to have, in this way, you have to have an external storage for this information. Probably you take notes, or you have some app, or use just a notebook. While recording this, you offload this cognitive. Make sure you are following a system. You are following a system so that it's easy for you to understand whatever you have offloaded later on. Later on, you can go back and organize this into a long-term memory. Long-term memory could be your own memory or another external long-term memory. But if you are taking too much so fast, try to use offloading. But during the intake, while you intake this information, try to apply some of these strategies. For example, don't understand examples on the surface. That's no compromise of that. Try to really get the correct amount, the correct level, by asking why and how. While you are reading, ask yourself why and how. You get the idea, offload to a specific external memory, move to the next, same, you offload again. After you offload, you free your working memory, you free your short-term memory, so no need to bother yourself humming here in the back of your mind of different things. You just offload, clear your mind, you now can focus on the next thing with a clear working memory. But again, proper strategies. Don't forget, at the end of the day or the next day, you go and review this. This is space practice, and you try to retrieve. And whenever you fail to retrieve, you try to correct yourself. Try to organize it. Try to organize it into more long-term memory, and try to give more concrete examples. If you didn't have time to do that during the session, try to do it later. But I think maybe this one is the idea here is to use offloading and external memory. And another thing is use a schedule and reduce the amount. Always reduce the amount of learning. Probably, maybe in the first place, your problem is that you are having too much. There is no, I always suspect whenever we have this problem, including myself and others who discuss with me, sometimes maybe we have this artificial uh, obligation that we have to do all of this. With age, you learn something. The best strategy is to have less on your plate. If you have too much on your plate, you cannot keep a diet, you cannot eat, you cannot do actually much. But if you have less on your plate, that's the best strategy. So try to, whenever you have some 5 things to study, make it 3, make it 2 if possible. Try to fight everybody, try to fight every circumstance and situation until you get to that point where you can take it one by one. After you finish the 2, you will come to the next 2, then you come to, this can be weeks apart, this can be months apart. Who said we don't have enough time? Actually, years will go, and instead of doing this, fighting with this inefficiently, is better to do this efficiently. I hope that resonates with you, Razin. I hope it was useful, although maybe later on we can elaborate on that.
Yeah, thank you very much, Doctor. Yes.
Okay, Razin. Okay, so is there any other comment or correction? Again, I apologize. We have taken 15 minutes more, although we started late, but I respect your time. So if nothing else, I really sincerely thank you for coming and sharing this session with us, sharing your valuable time. Hopefully this recording will be kept on the video. If you find this useful for anybody else, you can refer them to the recording. I hope that this will give links. Actually, it might not be very useful because I'm not the correct person to give information about that, but could be useful links. For example, could find some terms, and for especially the source of the talk, the book, some ideas. They can look it up from other. So it could be just a source of links and pointers for other more valuable information. So by that, I think we can call it a day, and we come to the end of the talk. Again, I repeat my thanking for everybody who is there and for everybody who will watch this later on. And I hope that you can make use of it. Thank you very much. This is the end of our session for today. Hopefully you join us the next month. Have a nice day. And I will stop the recording by now.
Okay, thank you very much, Doctor.
Okay. See you in the next talk.